We're diving into volume today, which is all about measuring 3D space. Think of it like this. If you have a big empty box, how much stuff can you actually fit inside? Volume tells you that amount. We measure it in cubic units because you're dealing with 3 dimensions, up and down, side to side, and front to back. Imagine a box full of tiny building blocks. The volume is the total count of those blocks. The specific 3D shape we'll focus on is the right rectangular prism. That's a fancy name for an ordinary box. Every face on it is a rectangle, and it has 3 key measurements: the length, the width, and the height, h. No matter how big or small, or what its dimensions are, as long as it's a standard box shape, it's a right rectangular prism. Before we get to the trickier fractional edges, let's quickly remind ourselves of the core volume formula. To find the volume V of any rectangular prism, you simply multiply the length by the width by the height. So V equals L times W times H. It's super important to remember that since you're multiplying 3 dimensions, the units in your final answer must always be cubed, like inches to the power 3 or meters to the power 3. Now for the grade 6 challenge. What happens when the length, width, or height aren't whole numbers? What if a container is only half an inch long? This is the core of standard 6.G.2. The good news is the formula V equals L times W times H doesn't change. We still use the same process, but now we'll be multiplying fractions and mixed numbers. It's just a way of calculating volume for smaller, more precise containers. You might wonder why we can use the same formula even with fractions. Picture this. If your prism is 1 by 2 inch long, you can think of it as being filled with little cubes that are 1 by 2 inch long on each side. The formula is essentially counting how many of those smaller fractional cubes would perfectly pack the container. The math is just finding the total amount of space, no matter how small the units are. Let's walk through the steps for solving these problems. The very first step, just like with whole numbers, is to clearly identify the 3 dimensions: length, L, width, W, and height. If you miss one or mix them up, the volume will be wrong. Look closely to see if any of these dimensions are given as a mixed number, a whole number next to a fraction, like 1 and 1 by 2 centimeters. This next step is absolutely critical and where most mistakes happen. If you have a mixed number, like 2 and 3 by 4, you must convert it to an improper fraction before you start multiplying. It's almost impossible to multiply 3 numbers accurately if one of them is a mixed number. Remember, to convert, you multiply the whole number by the denominator, add the numerator, and put that new number over the original denominator. For 2 and 3 by 4, that becomes 11 by 4. Once all your dimensions are proper or improper fractions, you're ready to multiply. The rule for multiplying fractions is pretty straightforward. You multiply all the numerators, the top numbers, together to get the new numerator. Then, you multiply all the denominators, the bottom numbers, together to get the new denominator. No need for a common denominator like you use in adding fractions. Let's try a straightforward example. Imagine a tiny box with dimensions of 3 by 4, 1 by 2, and 2 by 3 inches. The calculation is V equals 3 by 4 times 1 by 2 times 2 by 3. Let's focus on the numerators first. 3 times 1 times 2 gives us 6. Then for the denominators, 4 times 2 times 3 gives us 24. So the result is 6 by 24 cubic inches. We found the volume to be 6 by 24 cubic inches. But you should always simplify your final fraction if you can. Both 6 and 24 can be divided by the number 6. 6 divided by 6 is 1, and 24 divided by 6 is 4. That means the volume is 1 by 4 cubic inches. Always give the most simplified answer possible to make sure you get full credit. Now let's tackle one that includes a mixed number. Say we have a block of wood with a length of 2 and 1 by 2 feet, a width of 1 foot, and a height of 3 by 4 foot. Our first move is step 2. Convert 2 and 1 by 2 to an improper fraction, which is 5 by 2. Our multiplication now looks like v equals 5 by 2 times 1 times 3 by 4. Since 1 is a whole number, we can write it as 1 by 1 to make the multiplication easier. V equals 5 by 2 times 1 by 1 times 3. Multiplying the numerators gives us 5 times 1 times 3 equals 15. Multiplying the denominators gives us 2 times 1 times 4 equals 8. Our result is 15 by 8 cubic feet. The fraction 15 by 8 is an improper fraction, meaning the numerator is bigger than the denominator. While mathematically correct, it's generally better to convert it back to a mixed number for the final answer. How many times does 8 go into 15? Once, with a remainder of 7. So 15 by 8 is the same as 1 and 7 by 8. Our final polished answer is 1 and 7 by 8 cubic feet. Sometimes you'll see the volume formula written slightly differently. V equals B times H. The capital letter B stands for the area of the base. Since the base is a rectangle, B is just L times W. This formula is exactly the same. It just breaks the problem into two parts. First, find the area of the floor of the box, and then multiply by the height. It can be a handy way to organize your work. Let's use the V equals B times H method. Suppose the base has a length of 1 by 3 meter and a width of 1 by 4 meter, and the height is 2 meters. Step 1. Find the base area, B. B equals 1 by 3 times 1 by 4, which equals 1 by 12 square meters. This tells us the size of the bottom of the box. Now for step 2. Multiply the base area B by the height H. V equals 1 by 12 times 2. Remember, 2 can be written as 2 by 1. Multiplying gives us 2 by 12. Finally, we simplify 2 by 12 to 1 by 6. So the volume of this prism is 1 by 6 cubic meters. It's just a two-step approach to the same problem. This concept has a cool real-world application, packing. Let's say you have a large container with a volume of 2 cubic inches, and you want to fill it with tiny building blocks that are 1 by 2 inch on every side. The volume of one small cube is 1 by 2 times 1 by 2 times 1 by 2, which is 1 by 8 cubic inches. How many of those small 1 by 8 inch cubes will fit into the large 2 cubic inch container? To find out how many small objects fit inside a larger space, you always divide the total volume by the volume of one small object. So we need to calculate 2 divided by 1 by 8. Remember the rule for dividing fractions. You flip the second fraction, the divisor, and multiply. So 2 divided by 1 by 8 becomes 2 times 8. That equals 16. So you can fit 16 of the small cubes inside the larger container. Let's quickly review the big ideas. First, the simple formula V equals L times W times H still applies, even with fractions. Second, the single most important action is to convert all mixed numbers to improper fractions before you multiply. Finally, never forget your units. Volume is a 3D measurement, so your answer must be in cubic units, like centimeters to the power 3. It's time for a quick practice check to solidify your understanding. Pause the video and try to solve this one. Find the volume of a prism with a length of 1 in 1 by 3 centimeters, a width of 1 in 4 centimeter, and a height of 2 centimeters. Remember the steps. Convert, multiply, and simplify. The correct answer should be 2 by 3 cubic centimeters. If you got it, you're ready to ace volume with fractional edge lengths.